alien object that survived a journey into hell. An object from another star system just did something impossible. It dove straight into the sun's inferno, traveling at 68 kilometers per second, subjected to temperatures that vaporize metal. And it survived. But here's where it gets strange. Right as we were about to get our best look at this visitor, it vanished, hidden behind the sun for weeks. And when it reappeared, a Harvard astrophysicist claimed it had exploded into 16 pieces. NASA took 6 weeks to release photos from Mars. 6 weeks of silence. People started asking questions. What did they see? What are they hiding? And then the data started coming in, and nothing about this object makes sense. Welcome back to the Curiosity Beast, where we chase down the mysteries the universe throws at us. Today we're diving into 3I/Atlas, the interstellar comet that's currently tearing through our solar system. And I'm going to show you why some scientists think it might not be a comet at all. Let's start from the beginning. Since July 2025, astronomers have been tracking this object as it screamed toward our sun. It came from outside our solar system, which already makes it incredibly rare. We've only confirmed 3 interstellar objects ever: Oumuamua in 2017, 2I Borisov in 2019, and now 3I Atlas. But from the moment we spotted it, 3I Atlas started breaking the rules. In late August, NASA pointed the SWIFT observatory at the approaching visitor. SWIFT is designed to detect gamma-ray bursts, but its ultraviolet sensors can see something invisible to us: hydroxyl radicals. These are fragments of water molecules ripped apart by sunlight. And what SWIFT saw was shocking. At a distance of 2.9 astronomical units, nearly 3 times farther from the sun than Earth, 3I Atlas was dumping water at a rate of 40 kilograms per second. That's the output of a fire hose running at full blast. For a comet that far out, where temperatures are still freezing, this was unprecedented. Standard models say water ice shouldn't sublimate that aggressively until it gets much closer to the sun. Something was wrong. Either our models were broken or this object wasn't behaving like a normal comet. But before scientists could figure out what was happening, 3I Atlas disappeared. It dove behind the sun. And for the entire month of October, Earth-based telescopes were blind. This was the worst possible timing. The most exciting moment of the comet's journey, its closest approach to the sun, was happening on the side we couldn't see, when it would be at its brightest, when it would be outgassing most violently, and we couldn't watch. Or could we? While Earth was blind, we had probes positioned throughout the solar system. 3 spacecraft in particular had a perfect view: Stereo A SOHO, and the newly launched GOES-19 satellite. These spacecraft use coronagraphs to block out the sun's disk, creating an artificial eclipse. And what they saw was a transformation. For months, as 3I Atlas approached the sun, its brightness had been increasing steadily. Astronomers measure this as a power of the object's distance from the sun. Before October, the brightness was increasing at a rate of about R to the 3.8. That's normal for a comet. But inside 2 astronomical units, the brightness didn't just steepen, it went almost vertical. The new rate was R to the 7.5. That's a massive jump. The comet was shedding material at a rate that defied every model. It got so bright that by the time it emerged from behind the sun, even amateur astronomers could photograph it from their backyards. But the most telling detail was the color. For months, observers saw 3I Atlas as red, typical of dusty, organic-rich surfaces. Then it turned green, and then, through the solar observatory filters, it appeared blue. Blue is the signature of specific gas emissions: carbon monoxide, cyanide radicals. It meant that as 3I Atlas plunged toward the sun, the intense heat penetrated its outer dusty shell and began boiling off volatile ices from deep inside. The real comet, hidden beneath a protective crust, was finally revealing itself. Drop a comment right now. Do you think this is a natural comet? Or is there something else going on here? Because what I'm about to tell you is going to make you question everything. But the solar probes weren't the only ones watching. Just before its close encounter with the sun, 3I Atlas flew past Mars. It passed just 28 million kilometers away, and every robot we have on and around Mars turned to look. NASA's Mars Reconnaissance Orbiter, with its high-resolution camera powerful enough to spot a coffee table on the Martian surface, pointed at the visitor. If anything could get a clear image of the nucleus, it was this. But then something strange happened. NASA didn't release the images. Days passed, weeks passed. The US government shutdown affected NASA's departments, but 6 weeks, people started talking. Conspiracy theories spread. Had NASA seen something unusual? Something they didn't want to share? When the images finally dropped, they were underwhelming. A fuzzy, unresolved blob. The nucleus was hidden deep within a massive cloud of gas and dust, when 1,500 kilometers across. But here's what's wild. While we waited for those images, something incredible happened. The Perseverance rover, sitting in Jezero crater on Mars, pointed its cameras at the sky, and it took a photo. This is the first time in human history we have photographed an interstellar object from the surface of another world. Think about that. We just looked at a visitor from another star system, from Mars, and then came the moment everyone was waiting for, perihelion, the closest approach to the sun. As 3I Atlas emerged from behind our star in November, panic spread. Harvard astrophysicist Avi Loeb announced that the comet had fragmented, that it had exploded into 16 pieces. If true, our chance to study this rare visitor was over. But Loeb's concern wasn't random. For months, he'd been arguing that 3I Atlas exhibits behavior consistent with extraterrestrial technology. Now, before you roll your eyes, hear me out. Loeb pointed to two specific features. First, a sunward jet. Normally, comets have tails that point away from the sun, pushed by solar wind. But images from Spain's Canary Islands show 3 Atlas with a jet pointing toward the sun. Loeb suggested this could be a thruster, firing against the direction of motion, artificial propulsion. Second, he noted the object's remarkably straight trajectory. He argued that the mass loss required to produce the acceleration needed to maintain that path would be immense, enough to disintegrate the object. So when he calculated that it should have broken apart and it went behind the sun where we couldn't see it, he assumed the worst. But when new observations came in from the Lowell Observatory, astronomers reported that 3I Atlas was perfectly fine. No fragments, no debris cloud, the nucleus survived. So what about Loeb's evidence? Is there any merit to the artificial propulsion theory? If you're still watching, hit that subscribe button, because the answer is more complicated than you think. Let's address the sunward jet first. While it looks like a thruster, this is actually a known phenomenon in comets. As a comet approaches the sun, the side facing it heats up faster. If there's a weak spot, sublimating gases can shoot out toward the sun. The solar wind pushes this material back, creating a fan that from Earth's perspective looks like a forward-facing spike. We've seen this on Comet Halley, on Comet Neowise, on Comet 67P. It's unusual, but not unprecedented. Now, the straight trajectory. Loeb argues that the non-gravitational acceleration, the rocket effect from outgassing, is keeping the object on a suspiciously straight path. But a new study modeled 3I Atlas's trajectory over the last 100 years, and it found that the acceleration is entirely consistent with the water loss and massive carbon dioxide release we've observed. The comet is losing mass rapidly, just as it should. And its straight path is simply a matter of perspective. In a hyperbolic orbit, the object travels so fast that gravity bends its path less than a captured object. It looks straighter, but it's still following the laws of physics. And then came the smoking gun. The Meerkat radio telescope array in South Africa detected a faint signal at 1,665 and 1,667 megahertz. This is the absorption line of the hydroxyl radical, the signature of water. Radio waves can penetrate the thickest dust clouds. This detection confirms that 3I Atlas is venting water vapor. Lots of it. If it were a dry, rocky spaceship or a defunct probe, this signal wouldn't exist. This effectively seals the deal. 3I Atlas is made of water and carbon, the building blocks of nature. It's a comet, not an alien spacecraft. But that doesn't mean it's not surprising us. One of the biggest assumptions we make about interstellar objects is that they're pristine, perfectly preserved time capsules from the birth of their parent star systems. But new data from the James Webb Space Telescope revealed something shocking. 3I Atlas has 60 times more carbon dioxide relative to water than any comet we've ever seen. In a normal comet, the ratio of CO2 to water is about 0.12. In 3I Atlas, it's 7.6. This thing is practically a dry ice bomb. Where did all this carbon dioxide come from? A new paper proposes a fascinating answer: galactic cosmic rays. For billions of years, as 3I Atlas drifted between stars, it was constantly bombarded by high-energy particles. These particles slam into the comet's surface, penetrating meters deep into the ice. When they hit, they break chemical bonds. Over billions of years, convert simple carbon monoxide and water ice into carbon dioxide. It creates a processed crust. A layer of radiation burned chemical slag that extends 15 to 20 meters deep. What we're seeing right now isn't the pristine interior of the comet. We're seeing this cooked crust sublimating away. 3I Atlas has in effect caught the mother of all tans, and now it's peeling. But there's more. Spectroscopic analysis compared the light from 3I Atlas to meteorites found on Earth, and it looks remarkably similar to carbonaceous chondrites, rare primitive meteorites that contain tiny grains of iron and nickel, which means 3I Atlas might be carrying metals. And in September, the Very Large Telescope in Chile detected nickel and iron in its coma. This was unexpected. It's unlike any comet in our solar system. Why does this matter? When water ice melts inside the comet's porous crust, it comes into contact with these metal grains. In the presence of metal catalysts, water and carbon compounds undergo exothermic reactions. They release heat. This creates a feedback loop. The heat melts more ice, which reacts with more metal, releasing more heat. Pressure builds under the crust until the surface ruptures, and a jet of gas and dust explodes outward. This could explain the surge in brightness. The jets, the massive release of material. It's cryovolcanism, a comet erupting from the inside out. So where does 3I Atlas go from here? As of now, it's emerging from the solar glare. It survived its death dive, but the intense mass loss has likely altered its surface forever. It's now outbound, racing away from the sun and back toward the interstellar dark. But there's one more encounter coming. On March 16, 2026, 3I Atlas will pass just 0.35 astronomical units from Jupiter. It will fly inside Jupiter's Hill sphere, the region where the planet's gravity dominates. While it won't be captured, it's moving way too fast. Jupiter's gravity will tweak its trajectory one last time before it leaves the solar system. And if the Juno spacecraft is still operational, we might get one final close-up look at this interstellar traveler from the outer solar system. So what's the verdict? 3I Atlas is a comet, a natural object, but it's one of the strangest comets we've ever seen. Radiation cooked, metal laced, erupting from within. It's not an alien spacecraft, but it's a messenger from another star. And it's taught us more in a few months than we learned in decades of theory. Comment alien comet if you made it this far. And let me know, do you think we'll ever find an actual alien probe? Or are interstellar objects always going to be natural? The Curiosity Beast is all about chasing down the mysteries that challenge what we know. If you love this kind of content, subscribe, hit the bell, and join the community of curious minds who refuse to look away when the universe throws us a curveball. Because out there, between the stars, objects like 3I Atlas are drifting, waiting, and one day we might find one that isn't natural at all. Thanks for watching. Stay curious, and I'll see you in the next one.